The Battery Buzz podcast is brought to you by H.B. Fuller Company. H.B. Fuller is one of the battery industry's leading suppliers of adhesive, encapsulant, coatings, and sealants for the EV and battery industry. Hello and welcome to Battery Buzz, the show for battery professionals by battery professionals, keeping you connected to what's new with batteries and the people that help build them. Your battery specialist hosts, myself, Elizabeth Canaz, and Jermaine Maris Alvaraj, are back with our next episode. So thank you for joining us. And this week we're welcoming our special guest, Tom Stellmach with Mubea. And we're looking forward to discussing with Tom and getting his insights on the battery industry.
Yeah, so Tom Stellmach is the head of New Body Products business unit within Mubea North America, and him and his team lead and develop manufacture innovative solutions for battery and cooling systems. He's got a focus on leveraging roll bonding to create efficient and cost-effective cooling systems. Tom, you've been with Mubea for since 2015 in various roles within sales and engineering, all focused on system optimization, and you're out of Mubea's Michigan Engineering Center in Auburn Hills. And you have a Bachelor of Science in Mechanical Engineering from Lawrence Technological University. It's very cool. Tom, thank you for joining us.
Yeah, thanks for having me.
Yeah, very excited.
Yep, we're looking forward to hearing more about what Mubea offers. But we're going to jump into our next segment with what's new in batteries. So this is kind of giving you the latest and greatest news. So I heard on the news that Daimler Truck America and Proterra, a leading innovator in commercial vehicle battery technology, today announced plans to power Thomas-built buses, the next generation all-electric, the Staff T-Liner, C2 Julie School Bus, and the Freightliner Custom Chassis Corporation all-electric MT50E last-minute delivery truck using the Proterra's battery technology, which that's pretty exciting. I know Proterra is a U.S. battery manufacturer, and I know there's a lot of U.S. made, being encouraged here in the U.S. So that's good for Daimler Truck North America and for Proterra.
Yeah, absolutely. It's cool to see all these big names, like Thomas built all these big truck manufacturers that have been so big in the ICE engines to now make the switch. Those are huge names to kind of to make the switch happen. So that's exciting.
Yeah, I think leveraging a few companies working together will help them get good value buys too.
Yeah, absolutely. But yeah, so kind of along with trucks, another piece of news that I saw was at the Advanced Clean Transportation Expo. So Hexagon Purus up in Canada, they actually partnered with Hino Trucks, and they're announcing the launch of Turn. So it's a dedicated zero emissions truck brand. And this is along with their RC8, which is kind of their inaugural vehicle model. And so this is like a Class 8 tractor, all electric battery designed specifically for the US market. So kind of along the same vein, I think is really cool. One of the stats that I saw, which was very cool, is that they're kind of targeting some stats with the truck build, like a gross vehicle weight rating of 68,000 pounds, and kind of like a 200-mile regional city range. So it actually addresses about 95% of the use cases for that truck in its class. So to kind of make that all electric is very cool and kind of help transition that fleet into electric vehicles. I thought that was very interesting.
Yeah, that's really exciting. I saw a lot of partnerships coming out of the ACT Expo that were being announced. That it was a really exciting event. We didn't attend, but I was following it on LinkedIn.
Yeah.
Another really cool thing, so Goshen High Tech, it's a Chinese battery manufacturer backed by Volkswagen. They said that there's a new fast charging battery that's ready for commercial production. So this product that gives an edge against the rivals like CATL, the world's top electric battery producer. So the fourth largest EV battery maker in mainland China and the eighth largest in the world. So CATL is pretty big. So lithium iron phosphate or LFP battery offers a driving range of nearly 500 kilometers in less than 10 minutes of charging. So that's really impressive, fast charging that will help, help boost the charging duration that I know most people are, it prohibits people from wanting to buy an EV if they have to sit there for, an hour or two to get charged.
Yeah,
Yeah,
wow, 10 minutes, yeah.
the charge times help actually a lot with the throughput on the chargers too. So especially like the high population density areas like California where you have a lot of EVs, just them being on charge for a shorter time means that they're more available for more people.
Yeah, that's a good point.
That's
And
a great point.
I've even seen like at the grocery stores now, like all the parking lots have dedicated charging stations for EVs. So it's really becoming more and more accessible as well.
Yeah, hopefully in a couple of years, anywhere that you spend more than a half hour at normally, we'll have a charger outside so you can be full charged when you come back out.
Yeah. And it's interesting to see that it's different battery technologies too, right? This seems to be more of a LFP focus, but it's interesting that there's a broader range of battery technologies on the market. That's good too.
And it's nice to see some competition for CATL as well. So we need some more players out there in the game to help make this more sustainable.
Yeah, absolutely. But yeah. I mean, those are some great kind of new updates in the battery community in the battery world. It's constantly evolving, and it's crazy to see the rapid growth and the changes. But kind of speaking of someone who's been in the battery industry and have been able to kind of see multiple aspects of, you know, batteries and their manufacturers, Tom, we kind of want to get your perspective on things now and kind of get some of your insight. So, do you think you can kind of first give us a background of Mubea as a company?
Yeah, so I mean, Mubea in general, it's a 100-year-old family-owned company. Um, we don't really do kind of copycat products. We do a lot of like innovative products that are special in one way or another. So almost all the stuff we do is focused on lightweighting. So we do more traditional products like coil springs and stabilizer bars, but they're all special in a certain way to help them be lighter. But we also do aviation, so we're a top 10 European aviation supplier now. We do micromobility, we do composites where we make probably more monocoques than anyone else in the world. And then I work in our battery structures group, doing composite lids, underride protection, but also the roll bonded cooling plates.
Yeah,
Very
that's a
cool.
really cool technology. I saw a video that you guys had on your website where it's like a continuous line that just makes long sheets, and then you're able to, um, stamp them out. Can you explain a little bit? Like, I think our viewers would be interested in learning more about how how the cooling channels are developed in the within the plates.
So from the design perspective or the manufacturing perspective?
Both design and manufacturing. I mean, I think it's just a cool way that you guys are able to, create the channels within the plates themselves.
So the way that we're making it is essentially you take two coils of aluminum, you send them through an oven to soften the material, and then you send it through a rolling mill where you're basically diffusion bonding these two coils together. It's kind of like melting them together, but it's partial heat, partial pressure. Um, and then we do go through another oven afterwards to set the mechanical properties. Prior to going into the first oven, we're printing the channel pattern on with the screen printing process. It's done more or less like how you would make a t-shirt, just with the high melting point material. And that basically prevents the two coils from melting together in that area. And then at the end, that channel pattern lives inside of these two melted coils. and you basically inflate them like a balloon. So we hook it up to high pressure air at room temperature and inflate the channel pattern.
Yeah, that's a pretty
Very
cool
cool.
process.
Yeah. And do you get kind of what are the main benefits of that you'd see in kind of like high volume? Is there or something unique to your process or yeah, like what are the benefits that you see there with how you do it?
So, I mean, we're pretty low cost at high volume. The machine we have that makes them is massive and can turn out tons of plates per year. Um, but also, like from a technical perspective, the bonding that we're doing is a diffusion bond, and we have a really high bonded area. So the bond is super robust. So the two plates basically will never come apart afterwards. And that means because it's not, you don't have like a brazing material in there that has a lower melting point, so you can weld the cooling plate to surrounding structures. Even directly on the channels, you can weld the plates. But also you can use it more or less like a regular sheet of aluminum where you can form them
Hmm.
into tubs. You can bend the connector areas around corners to try to make it so that they're more ergonomic and things like that. So it helps fix packaging issues, fix leakage pads in the box. So
Yeah. And that's got to lend to pretty good like flexibility, right? Because you're just working. I mean, everyone's doing it differently. That's kind of the name of the game. Everyone wants to do it differently for whatever reason. So I'm sure the
mhm.
process lends to a lot of flexibility there, which is good.
Yeah, absolutely. And I mean the nice part about the printing the channel pattern like a t-shirt is we don't really have a tool for achieving the channel pattern. So if for some reason late in development you need to change the channels because you want to weld a bracket here, or you need to cool this other area so you can cool your control module or that you hadn't originally planned for, or something like that. It's basically no cost for us to change it. It's just changing out the screen print pattern, and
Yeah.
then we can have a completely new pattern in a week or two. Not that the EV companies would ever change their design late in the game.
No,
No,
never.
no. That'll be
They
crazy.
they stick with their plan consistently.
Right, right.
Yeah. So beyond that, like, can you kind of give us some insight? Like, what do you like working with the battery industry and cooling plates, and what is your experience there?
I mean, I think it's kind of what Jermaine mentioned is that every plate is different. Every battery box is different. So there's just tons of different challenges to work through, whether it's packaging or ergonomics. And I mean, the other thing is that it's not really just lightweight vehicles that we're working on now. So a lot of different fields are starting to electrify, like heavy equipment and trains and boats, and they all have their own requirements and special needs, which make them interesting in their own way, I would say. A lot of different challenges to try to overcome. Um, I mean, even from like a business perspective, there's a lot of interesting challenges in the EV market. The volumes, especially in the last 6 months when everyone keeps talking about the concern in the EV volumes, have made planning its own challenge. I would say capacity planning and like infrastructure planning. Where do you put your capital and how much capital do you put where has been a really hot topic as everyone else is talking about what's happening to their volumes. So there's just tons of different challenges.
Yeah, and we see the same on our end, lots of diversity and everything's, slightly different. It's, one day maybe we'll get to that cookie cutter project. But I don't think we've
Maybe.
seen that.
Yeah.
And it sounds like you're seeing the same things we're seeing.
Yeah, I think in the first generation of, I mean, I would say we're going into the second generation or so of battery boxes right now. Um, Everybody's trying everything, and I think there's not necessarily a clear right way to do the battery box. Um, there's probably been a couple of wrong ways that people have figured out to do them, but I don't know that anyone's figured out like what is the best way to make a battery box.
Yeah, that's a really good point. Super
So,
interesting. I guess. Oh,
no, go ahead, Jermaine. Sorry.
yeah, no, I mean, what interests me about that is kind of keeping that in mind. How do you kind of determine where you need to go, right? Or what changes you need to do? I guess how do you stay ahead of the curve in terms of kind of creating the battery boxes and following the different designs that everyone has, like dimension, like maybe EVs will do it a different way, tolls will do it a different way, trains and larger vehicles will do it differently. How do you kind of stay ahead of all that?
I mean, there's, I think you could read every day the rest of your life and not know what's already happened. That, for me, the easiest way is really just talking to people, networking, understanding lessons learned from other people that you just don't get from articles online all the time. Um, I mean, each one of them kind of has their own regulations that you have to keep an eye on. But usually, if you're starting into a new market, you have to just kind of get the crash course on like, okay, what is different about this market versus the other markets, and why is that important to you? But really, there's so much stuff going on in the battery industry right now. It's just, it doesn't, you can't do it all, and you have to kind of work with the other companies and try to figure out who can do what parts or what processes, what are they good at, um, and kind of work together to try to help each other here.
Yeah, it's definitely very
That's a really good point.
dynamic, I would say. It's forever changing. I guess what kind of challenges do you see though? What is your biggest challenge as as a manufacturer of cold plates and battery boxes? Like what do you see as your biggest, mountains to climb?
I mean, the volume volatility lately has been a tough one.
Hmm.
So spending a bunch of money on capital and then the volume's just not coming, has been tough. And then it's always makes for a tough conversation with the car companies because you want to work with them on the next project, so you don't want to burn the bridge, but you also spent a bunch of money that you have a hard time paying off if the volumes don't come. And I
Yeah.
think even within some of the companies, a lot of them are changing their strategy right now. So a lot of people are talking about, do we need to work on like a range extended hybrid, or do we
Mhm.
just want to work on hybrids only and maybe forego the full electric vehicles? And there are other companies who are doubling down on the full electric vehicles and saying, okay, everyone else is moving away. That means if I do a good job with the electric vehicles, the competition will be lower. So I every just the changing in strategy. It's such a dynamic planning field at the moment. It makes it hard, I would say. That's probably the biggest challenge.
Yeah. I mean, I was reading about, hybrid versus EVs and um it just seems like it's way more of I won't go down the rabbit hole, but it's way more money to make a hybrid than it would just to make a pure electric vehicle in my mind, without not having two different systems to maintain. So that's an interesting perspective though.
And I
Yeah.
think they give up a lot of their economy of scale, like the whole way, like if you think about like the light truck, the reason that you can get them relatively affordable versus how much capability they have is because they make 300, 400, 500,000 of this similar or same truck. And when you're introducing, rather than one or two powertrains, you have 10 because you need a hybrid and a plug-in hybrid and a range extender and a ICE and a V8, and it makes it that basic, and each one of them has a different frame. Each one of them has a different battery box, different cooling system. Your
Yeah.
economy of scale is just gone.
Yeah. That's true. I mean, I guess not to go down the rabbit hole Elizabeth was avoiding, but I do think though there is kind of I've seen just in marketing alone and some of the projects that have come across, where people are trying to see like, should we have started with the plug-in hybrid first to get more people into it, to get, more mass production.
Mhm.
Um, and so, yeah, it's interesting, right? It's almost like, are we taking a step back? I don't think it is that way, but you're right in saying we haven't gotten all figured out. I think we're all just trying different things and don't know what's going to stick.
They
Yeah.
have that one commercial out that's like I can't remember the car manufacturer. Maybe you guys remember, but they have a they have like a just a normal ICE engine. Then there's the EV, and then in between those cars, the girl drives out with a hybrid in between them. I don't know. I
Mhm.
can't remember what car manufacturer it is.
Hmm.
It might have been Volkswagen or something, but it's like they covered the entire gamut of each vehicle. So I mean, they've got to have a lot of different lines to be able to maintain that diversity,
Yeah,
and so it was just interesting. I wish I could
yeah,
remember what car manufacturer that was, but
yeah. But to your point, Tom, that's so much more complexity now, right?
yeah,
So what's the trade-offs there?
Right. And if you look at a lot of like the volume projections, most of them show like the plug-in hybrids at least remaining a relatively small portion of the market. So at least until 6 months ago, before everyone started getting nervous about their planning, the hybrids were forecasted to be like a consistent 10% while EVs grow and ICE shrinks. So I would be interested to see what like a lot of the big forecasting companies like Reuters or IHS show next year. Are
yeah.
they going to show a
Right.
30% PHEV segment, or is it just that the PHEV market is going to be oversaturated?
Yeah, that's a good point. Yeah. The oversaturation, I think, is a big risk that they have to weigh. Yeah.
Mhm.
But I guess kind of with all that, what are the major changes that you're seeing kind of with cooling plates in the near future? And I guess specifically with more and more the push with like the larger cell formats, or even without that, what are the big changes that you're noticing in the market that you're kind of having to adapt to?
I mean, I would say one of the big topics that we've had in the last 6 months that we probably didn't have a year ago is the off-gassing or thermal propagation management. So a lot of people are starting to try interesting configurations of cooling plates to try to improve thermal propagation. I think across the board, what we've heard is that the simulations of thermal propagation aren't so accurate. Um, so the only way that you really find out how well did your thermal propagation strategy work is during physical testing. So during development, knowing that it's hard to basically design to a certain metric because your simulation's not that accurate. Everyone's just throwing everything they can at the wall and seeing what sticks. And then when they test, they just hope it passed. And if it passed by a mile, they go, we're not taking anything out. We'll just take the pass and leave it how it is. So they're starting to try a lot of interesting things, even with the cooling plate, where we're yeah, a lot of different people introducing special geometries to allow for off-gassing from the cells and things like that. With the large format cells, they lend themselves more to the cell to pack and cell to vehicle. So we see that more and more. It's hard to implement, I would say, with certain formats. So the large prismatic cells basically allow you to assemble a cell to vehicle or cell to pack pretty easy. Whereas if you're looking at like a pouch cell or a cylindrical cell, there's just too many pieces to assemble them easier, or it's too difficult to get the compression you need to assemble them the right way. Or a lot of like the pouch cells have tabs which create interference issues um, kind of the cell to vehicle, and these large format prismatic cells are really making it so you can assemble a big battery box very fast. Um, Typically the large format cells want a bigger cooling plate, but we see also a lot of people trying to develop small cooling plates. It's kind of the two paths everyone's taking at the moment is either many small cooling plates, which are pretty thin, or like one big cooling plate, which is pretty thick, and then it can be a crash structural member to take some of the
Oh,
loading off of the body in white.
oh, interesting. That's very cool.
Yeah.
Huh.
It
Yeah,
makes for
it's
it's an interesting trade-off that a lot of people don't really
Yeah.
understand when you're looking at like the normal metrics people talk about, like how many kilowatt hours per kilogram are they getting? Because having a big, heavy cooling plate actually makes that metric look worse because you're just evaluating the battery pack. But if you can take a ton of weight out of the body in white by having your battery box take more of the crash load, you can get a pretty significant net save um, by using it. Basically, you have to leverage the whole system. Focusing on
Yeah.
one component is probably a easy mistake to fall into.
Yeah, and I can imagine
Yeah.
even just having one cooling plate with crash resistance, but then your cycle time is significantly reduced because you don't have a bunch of little ones that you've got to manufacture. So I think looking at it from a holistic approach is, I don't think is done a lot of times. I think it's done by part or,
Mhm.
section, and there's a lot of additional benefits that you could probably get by going that route.
Yeah, I
Oh,
totally
yeah.
agree. I mean, like if you use one large cooling plate for your battery box, you can get pretty similar performance to using many small plates. But you're spending a fraction of the cost because if you think about like a small cooling plate, you probably have, let's say, 5 to 10 of them in a battery box, where you have basically one per module in the box, but you have to cut that outer shape for every one of those. Whereas if you do a big one, you're only cutting it once per vehicle, and you have to weld a inlet and an outlet on for each of those 10 plates. If you do a
Oh,
big one, you can only weld
Yeah.
one per vehicle, so you're saving just by the lack of processing quite a bit of money by doing one big plate. Um, but there are people who we quote like one strategy with small plates and one strategy with a big plate, and at least from our perspective, it's hundreds of dollars per vehicle cheaper to go for the big plate, and sometimes they still choose the small plate, so there must be some advantage there in certain cases. So
mhm.
I'm not, I guess I'm not sure what the advantage is there, but there must be one.
Yeah, the one downside I could see is that reworkability. So if you do have like a
Mhm,
thermal event, you can't just take that little module out and replace it with a new one. I
mhm.
mean, that would be the main thing. I couldn't think of anything else that would significantly, impact it, but those are just my
Yeah.
thoughts.
Yeah.
Yeah.
That's interesting.
Sometimes they talk about the scalability, like if you include the cold plate in the module, um, it allows you to be more dynamic with which module you use. So you could build one battery structure and put in maybe 2 or 3 different types of modules into the same battery structure, and your cold plate kind of belongs more to the module than the battery structure. But I would think you could do the same thing with the cooling plate, where if the cooling plate was part of the structure, you could just put different modules on top of it and it would have the same kind of interchangeability.
Tom, you
Yeah,
got a
I
clear
mean,
favorite here. It's a little bit of a bias. Go ahead. No.
well, I feel like this should have been our battery banter topic, like
I
small
was gonna
plates
say,
versus large plates.
we've already covered this. Yeah.
I know. I picked the wrong
Uh,
topic. Well, I
yeah.
did. So, we could do either or. It's up to you guys. I guess we're kind of in that section already, but or we can discuss, passive or active cooling.
That'll be interesting too.
Yeah.
Yeah.
Well, we can dive into that. So I guess perspective, Tom, being, the expert. What are your thoughts on? I know, in some instances, like for e-bikes or big long haul trucks, they use a lot of passive cooling techniques. One, because the trucks you have space, and then in e-bikes or smaller ones, you don't have any space for cooling. So what are your thoughts on, active versus passive cooling methods?
I mean, I think in general, the reason you have cooling plates in vehicles isn't normally for like your normal day-to-day driving around. It's really either high performance driving where you have really fast discharging of the vehicle, or for quick charging of the vehicle if you really want level 3 charging. If you're only ever doing like level 1, which is like the regular house outlet, or level 2, which is like the 240 volt outlet at like your dryer in the garage outlet, um, you don't really need cooling plates. Like you can typically get away with passive cooling with level 1 and level 2. You really only need water cooling for level 3. And I think so some of the early vehicles did just use passive cooling, like the Nissan Leaf had passive cooling in the beginning. I think some of the early Hyundai Kias used like an air cooling, which was kind of piggybacked off of like the HVAC system. Um, so as long as people are okay with a lower charging speed, you don't really need the active cooling. It's really just the high performance. And I mean, uh, a lot of people are asking for low cost EVs right now. And I think I know a lot of people are really concerned about the range thing. I drive an electric car every day, and I charge about every third or fourth day. And you don't really need a level 3 charging. I do level 2 every third or fourth day, and I drive, I don't know, 15,000 miles a year, and it's not really an issue. So I would say for me, I wouldn't really need a cooling plate in my car. It's just people have to grow a certain level of comfort with it, I think.
Yeah, and I don't know if
Yeah.
people are willing to accept the slower charging rates, I guess. It seems like, well, I mean, you just hear people talk like, I don't want an EV. I don't have to sit there for, an hour, while I'm driving, from, San Francisco to LA, over at the Grapevine, because that's where the charging station is. And, so it's kind of I think in people's minds, it's a big deal to them, like, because they're used to just, putting in the handle and getting their gas and then taking off. So I
Right.
think it's a mind shift to overcome.
Yeah, I think it really is just a mindset thing. Like for most people, the number of times in a year that you drive more than 200 miles in a day, you can probably count on one hand. And you could probably rent a car for that day, or use like one of the ride sharing things. Um, I think it's really just people have to be more comfortable with understanding that you don't go to the gas station every day, so you don't need to charge every day either. Um, but I think having an EV for your first time and kind of growing that comfort level is kind of what it takes.
Yeah,
But I
I
also think
agree.
safety, I think having a cooling plate really contributes to keeping those batteries cooler. I mean, they are going to heat up. And especially if it's hotter outside, you're not going to have that system to cool for safety, I think that that's another aspect that I think cooling is important for thermal management.
Yeah, I think it depends a little bit on where you live. I know that the original Leaves got a lot of bad feedback from people who lived in Arizona. But they're also like the original Golf E. They did a study where the first generation, they did have water cooling, and they did a ton of testing in Dubai, and they found that they didn't really need water cooling. So in the second generation of the Golf E, they took the water cooling out.
Hmm.
Um, so I think it depends a little bit on your cell type and how sensitive to the temperature changes it is. And I think it also depends a little bit on how often you park your car in a sunny black parking lot. Um,
Well, Jermaine and I can attest to this. We were in Arizona last week and it was 118 degrees. And there was a bunch of EVs sitting out in the parking lot. And I was like, I wonder how hot those batteries are right now because it was intense. It was like frying, like, I mean, from the door to the car, it was so hot.
We were struggling. We were struggling.
And I was like, that battery's got to be like 200 degrees F sitting in that car on the cement with all the reflective, metal going on it. So I don't know. For me, I think I want some active cooling if I'm driving an EV.
yeah. Well, it's like the don't leave your dog in the car kind of thing. You're
Oh,
worried about your batteries out there.
I mean, I was just thinking they're going to just spontaneously start combusting everywhere. It was so hot.
Yeah.
Yeah.
Oh man. Yeah.
But I know in a lot of applications we've done passive cooling and, there hasn't been any issues with that.
I mean,
Yeah.
I think it's a whole strategy you have to get into for it. So it's not that you can't take the same or probably shouldn't take the same structure that you would for a battery cooling box and just take out the cooling. You have to kind of use the box itself as a heat sink. You could tim you don't, without a cooling plate, you could potentially tim the module to the housing to try to dissipate some of the battery energy into the housing, which would help you during charging, but would probably hurt you in Arizona. Um,
Yeah.
but
Yeah, I don't know if you want a metal housing there.
right. Yeah, I think it's just an expensive system though. If everybody's complaining that the electric cars are expensive when they're 35, $40,000, the cooling system is probably in the realm of $5,000 if you count the plates and the hoses and the pumps and the connectors, your radiator. Like it's a lot of weight, which hurts your range. Um, Maybe not a good look as the guy who works on cooling plates to say you probably could get away without them, but I think if that's really the low cost target, then I think it's something people should consider. Really, what is your target audience?
Yeah. It's hard to weigh, right? Because I think the mindset that you were kind of talking about is if you're going to spend that much money on an electric vehicle and make that lifestyle switch, you kind of want something that can do everything. And so, yeah, maybe your normal day isn't driving 200 plus miles, but if you ever do, you want to make sure that you're set, so that, with the charging and everything and the reliability. So it's a hard kind of where do you draw the line in the sand, right? As to what
Mhm.
matters. So I think we're all kind of weighing those questions. It's interesting.
Yeah, I mean that's why I think the hybrids and the plugins are becoming more interesting is just because it gives people the ability to do it all. And um I mean, but on the same point, the hybrids, a lot of them don't have cooling because they're really only meant to do level 2 or the smaller ones because they have such small batteries. Even a level 2 battery charges in like 2 to 4 hours depending on battery size and whatnot. um and it gives them a lot more design freedom on their packs. Like you don't necessarily need to use a metal box. You could use a cast aluminum box. You could use a plastic box, which is I think a more interesting idea that's starting to find its way out there. Because especially on like hybrids, it's a generally an ICE vehicle. It's designed for most of the crash load cases, and they're just hiding a battery pack somewhere in the vehicle. If it's not structural, you could make it out of plastic. And if you don't need a cooling system, it makes it a little bit easier. Um,
Yeah, good
so
point.
a lot of, I mean, that's why all of the electric vehicles are different. They're all special snowflakes because there's different customers, there's different requirements and targets. It'll be interesting to see where we converge, I think.
Yeah.
Yeah. I do think it'd be interesting. I mean, I think in my opinion, I would prefer just to go straight EV versus hybrid. Just that's just my preference. I mean, I took a lift to the airport the other day, and I was a Prius. It was a newer Prius, and I was asking him how he liked his car and how much range he got. And he said basically, like the battery lasts, for the duration of his trips, and when that runs out, he switches over to gas and just continues on, so I'm sure he's doing a lot of, pickup drop off driving all day long. But I mean, it is a smaller car too. That's the other thing you have to
Yeah.
get used to if you
Yeah,
want to drive a smaller vehicle. I think most people want a big truck or a big SUV. That's us in America. We like our big cars.
right. And I think the hybrids, like the value proposition is not always there. Like the buyback point is often 150,000 miles or more, where you basically the savings in fuel overcomes the on cost of a hybrid versus the ICE vehicle. And I'm sure like even the buyback period on the carbon footprint, because they spent so much more manufacturing making that hybrid, is probably also like 100,000 miles or more. So it isn't always the best solution, I don't think. It, yeah. I mean,
I
even
think
like
about that.
the Wrangler also, if you think about the Wrangler, I think the fuel economy of the PHEV Wrangler, 1 year battery does run out if you're not diligent about charging it every night, you can get worse gas mileage than if you had just bought the ICE one.
That's funny. That was the other thing that the guy, my driver was said was that the cost to replace the battery was much cheaper than if he had an EV, which
Hmm.
I have seen some of the ranges for some of the cars. I think they range anywhere from 5,000 to like 15, 20,000 to replace the battery. And, he's like, well, how long does that battery actually last? So I mean, those are all interesting, comments there. But yeah,
Yeah.
that's
Well, then, yeah, you have that maintenance plus your normal everything that you got to do with a nice engine. Like, ugh,
Yeah,
I don't
true.
know.
With the hybrid, you don't get 2/3 of the benefits and you get somehow all the downsides.
yeah. So I don't know. I don't know. We'll have to see. We'll see the great debate. We'll reconvene in a year and we'll
Yeah.
we'll look at some numbers. It
Yeah,
might
we're all gonna look really stupid if plugins are on top. We're gonna have to delete this one.
Yeah.
it was Tom's idea.
Yeah, really, yeah, yeah.
I think there's a lot of them that are pretty interesting that are coming out. I think a lot of the hybrids on the market now have pretty low ranges. Like if you think about the long range hybrids, you have maybe the i3, the BMW i3 is still a pretty long range extender version. That's still only 100 miles and you have to fill up every 80 afterwards or something like that. So it's not really a convenient one, but some of the ones that are coming out, like the Dodge Ram Charger, I think, is supposed to have 700 miles range where you have basically 100 on electric, and then you have a gas tank, which is running your engine, which is a generator that charges the battery. And you're supposed to basically be able to use a full tank of gas to charge up the battery a handful of times. Um, and I think something like that might be more familiar to people, where on a 100-mile charge, you can cover most of your daily driving needs. But if you don't plug it in, you can still just fill up at the tank or at the gas station, and it you have that short fill up time.
Yeah. Yeah, it's interesting. I think we're all kind of, I don't know. I don't think we've not found the sweet spot. You know what I mean? I think it's so different for everyone. It's so hard to make a cultural shift for everyone when everyone's perspectives are different. And I guess, that's the problem that they're having. I totally get it. But yeah, it's hard. interesting though.
And
It's
I
fun.
think with the larger OEMs, I mean, they already have, building a car manufacturing, a normal internal combustion engine down. And it's a struggle to switch to, a battery, manufacturing line, which I think looks different from most aspects than, an internal combustion engine. So I think there's a learning gap that needs to happen as well.
Yeah. And like how they manufacture, right? Do they still do it
Mhm.
at the tier level, like how they've always been doing it? Do they all do it in-house?
Yeah, I think the
It's different.
relationship's really different between the OEM and the tiers with the battery vehicles.
Yeah, exactly. I agree.
But I think we really should, we'll plan on reconvene and having this conversation a year from now and see where these things lands. I think that'd be really an interesting conversation to recap here. Seems like there's a lot of unknowns and some be interested to see the outcome of that.
I'll bring my helmet for the follow-up.
You're lucky this is virtual.
Yeah.
Well, I think that's all the time we have for today. So thank you for joining us, Tom. It was great having this conversation
Thank
with
you.
you and hearing your perspective on this. So we will have another special guest on our next episode. Jake Hawksworth from Hypercraft joining us to discuss his take on the battery industry.
Yeah. So yeah, as Elizabeth said, Tom, thank you so much for joining us, and the discussion has been great. For everyone listening, if you have any comments or questions on today's discussions that we've had with Tom, feel free to comment or give us your insights. And then also, obviously, please subscribe, like, follow, and check out H.B. Fuller's electric battery adhesives page on LinkedIn. Yeah, thanks everyone.
All right. Thanks, everyone. Have a great day.
Thank you. Bye.